Good morning and welcome back. Tuesday, this is April 28th. We're nearing the end, it's hard to believe, of April. We're moving into May. Our school year, May, June, that's it. And we don't even go all the way through June. So we'll see what it ends up looking like this year. But today, what I wanted to go over is weirdness in evolution and some of the things that people commonly bring up as arguments against the theory that we actually have evidence of quite the contrary. We have evidence that supports evolution with this, as opposed to actually like being threatened by it. So, I want to start today talking about something pretty straightforward. Turn this around. Quite often, throughout evolution, and for people who want to argue against it, there is a very common idea that is often used, or argument, I should say. Wow, that's a terrible line there. All right, this is the common argument. Let me try to turn. There we go. Now there's no glare on it. This is my very poorly drawn eyeball. Now, the argument goes that the eye is this unbelievably complex piece of biology. Now, I don't know if you guys remember this when we went over it with the nervous system in the human body, but if we turn the eye sideways and we cut it in half so that we can see what it's built like, you have this big area that comes all the way around, right? And that's going to be your retina. Oh, I apologize. Let me tilt this down just a little bit. All right, so you're going to have your retina there. You're going to have the iris, which is actually a series of muscles along the inside of the eye. And then you're going to have the lens. Fitting in there. And the muscles from the iris attach to the lens, and that's why your pupil gets bigger or smaller, because the iris is flexing in order to change the shape of the lens in order to better send an image to the back. And then the inside of the eye is filled with vitreous humor, which is kind of like a gel, helps to keep the eye round. And then we've got our cornea out front. And inside here is filled with what we call aqueous humor, which is more watery. But the whole thing, it's a very, very complex system. And then, of course, we have all of those nerve connections and those blood vessels that have to take that signal back to the brain and make sure that all the cells get all the stuff that they need. All right, the eyeball is a really complex organ. And the argument has long been that the eye is proof that evolution cannot be. Because if you try to think about an eyeball, it doesn't work if even a single one of these pieces aren't in the right orientation and aren't put together in the right way. It's been a very common argument. Well, it turns out we've actually done experiments based on an eye. And what we were able to do is we were able to show, let me adjust this once more. I'm just not going to get a good scenario, so I'll do it over here. We were able to show that if we give an organism a little bit of a light sensitive patch, just something that can detect light yes or no, well, Through the process of evolution, the next advantage for that organism is to be able to tell where the light is coming from, not just yes or no. And so what we see happen is that thing starts to form a depression. This is now a side view. So this would be going in against the face. So now when the light is coming at certain angles, we can get shadows. And that helps to tell the organism where the light's coming from. Well, as that cup, as that bowl, that recess, whatever you want to call it here, gets deeper and deeper, which you guys are not seeing clearly, we get better and better shadows and better lighting. And we've been able to prove through computer models, through animals that exist today who have simpler eyes than we do, through animals that exist today who have different eyes than we do. And that may sound weird, but we have very good proof that the eye has evolved not just once and not just twice, but literally dozens of times in completely unrelated organisms that didn't start with it. If you've ever seen the eyeball of a cuttlefish, if you don't know what a cuttlefish is, that's totally normal. For America, most people don't know what a cuttlefish is. They don't live near us, so we don't know what they are. But they're this really cool relative of squid and octopus. Normally, we would watch a video for them in school. Yes, they are amazing, Maddie. Amazing. Um, and I'm gonna try to find you guys a copy of it that you can view. But the problem is, if I try to broadcast it, that's copyright claims. Really can't do that. But their eyeball is shaped in kind of a circle like ours, but their pupil isn't a hole. It's this weird kind of W shape. I kid you not. Shaped like a W. Now, their eye and our eye obviously had to evolve from different places. Their structure is almost completely different from ours. We could take a look at an insect. An insect eye, if you zoom in on it, you guys are probably already familiar with it. I'm going to simplify this. An insect eye is faceted like a gemstone, and every pane of it can take in a separate image, which is one of the reasons why bugs are so good at getting out of the way when something's coming after them, because they can see it approaching from many, many different angles. The first video that I have for you guys today is actually a really cool one. It's an older video, though. It's from Professor Dawkins. He was a very, very famous scientist in his day and unfortunately just passed away not too long ago. But this is a video from the 70s, but he goes through, it's not too long, I think it's about 8 minutes, the evolution of an eyeball and exactly how that works and backs it all up with the evidence. Literally, not just talking about it, but he has a model to show you every step of the way as we went through this process over here and talking about the comparison between other ones there. Yeah. If you take a look at a lot of animals, like simpler animals, invertebrates especially, you'll find that their eyes are wildly different than ours because we evolved on very, very different tracks and have not had a common ancestor in a incredibly long time. So that's going to be part one. Is take a look at the evolution of an eye and how our evidence works from that. Now, the second thing I want you guys to do today is you're going to be watching a video called Nature's Giants. Now, this one is Giraffe. If you are not aware, Nature's Giants is a series that I believe it was National Geographic did for a while. And what it was animal dissections. So what happened was an animal died, usually in a zoo, and they called in this team. Richard Dawkins was actually a part of it. And they came in and they would dissect the animal publicly so that other veterinary students could watch it, going over the different parts, the different things that you find. Um, I showed you guys a little clip of it when we were in the classroom talking about the digestive system to show like the size of an elephant's guts. This one is just one segment of it. I think it's about 4 minutes long. But basically, what it's going to look at is it's going to look at a very particular nerve inside the giraffe that's responsible for controlling its voice box. And similarly, we have that same nerve, and it's evolved in the same pathway for us. But in giraffe, you really get this idea that, remember, evolution has to work with what it's got. New traits don't like spontaneously appear. In general, you will never have a species just spontaneously have wings. Right? Like, you guys may not think about it, but to make something new pop up, let's imagine we take our mouse, right? Remember our mouse from the evolution project. All right, if we wanted a mouse to have wings, these are my wings, even though they look like, I don't know, uh, French fries, big French fries. Anyway, think about all the other things that are involved in order to have those wings. It's not just a matter of having the wing shape, but you're going to need the bone support. Wings can't just exist on their own. Insect wings are made out of bone too. It's made out of their exoskeleton. Right. Adriana is mentioning right now what the giraffe video is really talking about. But in order to have the wings, we're going to need the bone to support it. We're also going to need the muscles. Need big, strong muscles in order to flap wings rapidly. But if we're going to have muscles that need to be able to flex, then we're also going to need the nerves. And if we're going to have bone and muscle and nerves that are all staying alive and doing their thing, well, then we're also going to need our circulatory system. And this is just like the slightest idea. So, since evolution can't do big jumps at once, it needs to do smaller ones. It needs to do small changes to traits that already exist. So, in this scenario, what we're looking at is this is my head of a generic animal, right? I don't care what it is. Just an animal, right? Now, here's its neck, and you've got your voice box in here. It's not literally a box, but I'm just going to draw it like this. Now, that's responsible for all of our ability to vocalize, to make noise, like you're listening to right now. You would imagine that from the brain, right up here, with all of its little foldy weirdness, and then our brain stem, you would imagine the connection goes bloop, as the brain as that goes down the spinal cord. What you're going to find out in that video is that, once again, evolution can only tweak what it has. So, if it didn't evolve this connection first, there might be other things that are in the way to it. There's all sorts of mistakes that happen with evolution. Things that get left over that don't have much of a purpose. We already talked about them once. Things like our appendix, our wisdom teeth. They are all what we call vestigial organs. They're all no good to us anymore. Well, turns out it got that needs some focus. There we go. There's a lot more than that. And the second video, or sorry, third video that I have for you guys today is once again not long, only about 6 minutes, and this is from It's Okay to Be Smart from PBS Digital Studios. And basically, he's going over where evolution has failed inside the human body. And it's really interesting to kind of get an idea of where we have these things that we don't need, this stuff that doesn't help us. Not just looking at like vestigial organs, but also design that just doesn't work. And I think that you guys can find that interesting, right? Like, there's some stuff in there that you guys are gonna, he'll be bringing up, and you'll be like, wait, what? Yeah, yeah, you're right. That doesn't make any sense, and it's because evolution can't plan ahead. It can't organize knowing where it's going. It can only work at that time with the traits that it has in incremental steps. And so the process does the best that it can with what it's got in the place and the time that it's got it. And that will result sometimes in mistakes, things that don't fit now that might be bad. Case in point, look at something like a polar bear. Polar bears are very, very well adapted for living in the Arctic. The cold weather, if you aren't aware, a polar bear doesn't have white fur. Its fur is actually clear and it's shaped like a funnel. So light that hits it bounces in and in and in, smaller and smaller until it finally reaches the skin of the polar bear, which is black. Polar bear skin is black. So that way, all the light that hits them gets funneled down in and absorbed by that dark skin to help keep them warm. Great adaptation. Unbelievable. It allows them to maintain a body temperature in an area that routinely is well below freezing. Except now it isn't. Now global temperatures are going up. We have been recording temperatures in both the Arctic and the Antarctic that are in excess of 60 to 70 degrees. What happens to a polar bear when it is put into a 70-degree location without a means to cool down, without its normal capabilities? Nothing good. It's got all these adaptations that keep it warm. It doesn't have adaptations to keep it cool. And so now, if the polar bear is to survive, it's going to need to evolve. And it can't just spontaneously, boom, have sweat. That's not a trait that the polar bears currently have. They're going to need something else. They're going to have to evolve based on what they have. Maybe the dark skin is no longer good, so now their skin starts to go lighter. Maybe the clear hair that funnels light isn't good, and maybe one of them is born with hair that's solid or more solid, so less light gets to the skin. That might be helpful. Remember, it's always tweaking what things have. Well, not to get too far into it because this is really going to be ecology, which we will be starting next week after the test, but that's human impact. And one of the major reasons that we're so concerned with it now is that we've got a lot of animals who have evolved to live under very certain conditions that have been this way for hundreds of thousands of years since the last ice age. And then in just the last 400 years, now that may seem like a lot to us, but it's not a long time to the planet. 400 years is a snap, it's a drop in the bucket, it's barely perceivable to the planet. And we have changed everything. And so now, as we clear cut trees, as we change the temperature, as the oceans get more acidic and all the corals are dying off, as all of these changes are happening, they're happening so fast that the biggest danger is that animals' natural evolutionary mechanisms can't keep up with it. And if they can't keep up, they will go extinct. There's always a rate of extinction in the background because some animals can't keep up. That's normal, that's natural, that's okay. The problem is now the rate of extinction is, I think it's something like uh, roughly 1,000 times higher. So per year, on average, let's say maybe 4 to 6 species go extinct. That's the natural background rate of extinction. Well, now it's 4,000 to 5,000 species go extinct every year. And that is exclusively from the studies we've done related to us and what we're doing to this planet. We'll talk way more about that in the next unit. But for today, I want you guys to be able to take a look at these evolutionary weirdnesses and kind of get an idea for how they help support the theory. Because they all do. Everything that we have studied does support it. Thus far, maybe one day it will be proven wrong. And if it is, as much as I love the theory of evolution and I'm really one of its little fanboys, I will jump on that new bus. Because if they can prove it's wrong, then we're still moving forward and we are still learning more about how everything happens. So, ladies and gentlemen, I hope you enjoy the day. It's pretty easy. Couple of videos, about 15 minutes. And after that, time for you guys to get whatever you need to done. Tomorrow, we're going to look at the weird and odd world of sexual selection and what that means. Darwin was once quoted as saying that the sight of a peacock makes him sick. Tomorrow, we'll explain what that means. Have a great day.